So in this video, I want to talk about what you're doing in Project 3. So in the first several parts of Project 3, what you're doing is you're making a model that tries to predict whether a patient is going to die in the ICU or whether they're going to survive. So in part 6, you're starting to look at, well, if we use this model in a hospital setting, what would it do? How could we use it? So here's the scenario at first. So we have 25 patients that the doctor who's starting their shift, they're kind of in charge of, and the doctor has 60 minutes to review all the charts for all the patients. So some of the patients, so the green ones here, they're going to be fine no matter what. There is no intervention that's needed. So some of the patients, let's say the ones that are marked with blue dots, those are the patients who are in danger. So if there is no correct intervention, then those patients are going to die. And we assume that in the validation set, there was no intervention, so that's why they died. This is not quite realistic, but this is what we assume. So now the doctor has 60 minutes to review all 25 files and decide on an intervention for each person. And we assume that this is the formula for the probability of failing to come up with the appropriate intervention, right? So for example, if we plug in 2.4 minutes, so this is how much the doctor gets per patient if they have 60 minutes for 25 charts. So if you plug in 2.4 minutes, you'll get like a 94% chance of failure, which, well, maybe it's a little bit realistic because 2.5 minutes is really not a lot of time to come up with an appropriate intervention. So the first thing that you need to do is you need to actually predict how many patients are going to die. So if that is the policy, so the doctor goes chart by chart, tries to decide on an intervention, if any, and has a 94% chance of failing to come up with the correct intervention. So how do you compute that? Well, the patients who are going to live, they're fine no matter what. It doesn't matter. For the patients for who are in danger, so of those you have 10, right? And you have 15 patients who are fine. So for the 10 patients who are in danger, there is a 94% chance of failing to come up with an intervention, assuming that t is equal to 2.4 minutes. So what you'd expect is that 9.4 patients will die, kind of on average, right? So that's kind of the answer. So the next question is, okay, so let's say that we are actually using our model in order to decide which patients to look at, right? So the model is going to look at each patient, and if the probability of death according to the model is greater than 50%, the model is going to say this person is in danger, right? So maybe it'll say this person is in danger and this person is in danger, and maybe there is a false positive here and maybe there is a false negative here. So it would be something like that. So what do you do next? You say, okay, so the doctor still has 60 minutes, but they have, they have just 3 patients here. Maybe there's more that were marked as being in danger to review. So they have more time per patient, so you compute the new probability of failure. Once you compute the new probability of failure, you have several classes of people. So you have the people who are going to survive no matter what, so they're fine. You have the people who the system did not say are in danger but actually are, right? So for example, this person. So that person is definitely going to die. And then you have the people whose charts the doctor is looking at. The doctor has an amount of time that's 60 divided by the total number of patients that the doctor is now reviewing, which is all the patients that are flagged. So you have the probability of failure, and from that you compute the expected number of people who will die. You add up all the people who will die, and that is how you get the figure that you need.